So on this one right here, the recommendation is to use dot paper and cut things out. Now for kids, I highly recommend they do that, cut things out and rearrange them. It's a little tricky to do it on the geoboards with a single colored elastic. You kind of need multiple colors to make it happen. I put a note in my post about the assignment here. Is that if you're not going to cut things out, you kind of have to draw successive pictures. So let me open this in a new tab where it's a little bigger. Yeah, so here's my original parallelogram I made. And then I made a note that I could chop off this triangle on the edge. And then I'm going to pick that triangle up and I'm going to stick it on the other side. When I do that, I build this red rectangle instead. So the point of this activity is that any parallelogram, you can chop off a triangle on one side, stick it on the other side, and you've made a rectangle. So you just want to make a few different demonstrations of this on your dot paper. A parallelogram turning into a rectangle. So give it a shot drawing something, and then we'll take a look at some of your drawings, make sure we're all on the right page there. Oh, why would we care to turn a parallelogram into a rectangle? It's easy to find the area because we measure area in squares, and rectangles are made up of squares more easily. This is 14.2, activity 14.2, correct.
Is this what we're doing on Monday? It's just finishing up stuff with the dots? Or are we going to be done with dots then?
On Monday, we're going to be done with dots. There might be a little bit of review.
Okay.
But we're going to be playing more with circles and other shapes on Monday. So just draw a few different ones.
Are we only supposed to cut off one triangle?
Yeah, you cut off one triangle and just stick it on the other side. Yeah, so for me here, I'm saying I'm cutting off this one right here. And I just picked it up and put it over there.
What number is this for?
This is activity 2.
Is there a certain number? Just
It is the second part.
Okay.
It says construct 5 additional parallelograms on your dot paper. Draw an altitude. Move it over. There. So the cool discovery here is that the area of a parallelogram is exactly the same as the area of a rectangle, provided we have a proper height. Is activity 4 missing from your packet? It is missing from my scan.
No,
Mine jumps from, oh.
you lost 2 too.
Oh, I know what happened. I forgot to copy it double-sided when I did it this way, I bet. Yeah, I'm missing every other page. Okay, that explains something. All right, I'll be right back while I get a better scan.
So we should have 6 of these total?
No, you can just do 5 total.
Okay.
That's fine. I'll be right back. I can get a proper scan. Where did I put it? All right, and once you get those done, take a look at activity, skip over activity 3, take a look at activity 4.
Are we doing activity 3 or something?
We're just going to skip it for now. I think we'll come back to it. Let's see. On the scan of this now. Come on.
Do you have any whiteout?
I do not have any whiteout. Okay, this one should have all the pages in it. All right, so activity 4, we're going to play around with a trapezoid. So this one is a little bit trickier. So what's happening on this one right here is we are doing a 180-degree rotation of the trapezoid to see what we get. So let's take their example right here. So we're going to build trapezoid A, B, C, D, just like they did. And we'll take a look at its area in a few different ways. All right, so everyone got that reproduced somewhere? You can. I have more dot paper if you need it. Yeah. Anybody else want more dot paper?
Yes, I have it.
We're making ABCD.
Yeah, so make ABCD first. And then once you get ABCD drawn, you're going to make a copy nearby and then attach to it one that's rotated 180 degrees. So imagine this one right here. If we just flip it 180 degrees, then we'll get this, and we can put it right next to it like that. So whereas before we had a base of 5 and a top of 2, When we attach the next one to it, it has a top of 5 and a base of 2. To get from the lower left up, we go up 2 over 1. To get from the upper right down, we go down to the left 1. So some observations, this new figure where I've taken that copy of the trapezoid and rotated it and stuck it back on, I've now made a parallelogram. Agreed? It has 2 pairs of parallel sides. We know how to find the area of a parallelogram. So for a parallelogram, all we have to do is take the base and multiply by the height. Well, the base here is 5 plus 2, which is 7. And the height here has to be perpendicular. What's the name of that perpendicular height if it's not already an edge on the figure? Anybody notice that word in the last activity? If it's not already an edge on the figure, that line, that red line I drew has a special name. It's called the altitude. Yeah, it's the altitude. And the altitude is just the difference, the distance from the base to the highest point. Like the altitude on a mountain kind of thing. The altitude here is 2. So this parallelogram has an area of 14. Now, how is the parallelogram related to our trapezoid?
It's the same, just
Not quite. It's, yeah, the trapezoid is half because we took 2 trapezoids to build this. So for our trapezoid, what we want to do is take that 14 and divide it by 2. So our trapezoid must have an area of 7. Okay, so what I'd like you to do is build a couple of different trapezoids from this one on your dot paper. Do the same, make a copy, flip it to turn it into a parallelogram, and figure out the area. And then from that, we'll derive a formula for the area of a trapezoid. But we got to get a couple more examples first. So make a couple of trapezoids that are different than this one and try the same procedure on it. So I've got one more example up here. You can just bunch it up here. Does everybody have at least one more drawn? Just about. All right, so let's take a look at mine up here. I just want to summarize a couple of things from it, and then we'll double check that it works on each of yours. So some terminology about a trapezoid. A trapezoid has at least a pair of parallel sides, right? Oops, I could spell parallel sides. The parallel sides are called the bases of the trapezoid. So a trapezoid has two bases. It has a base 1 and a base 2. Usually the way we orient them, we call one a bottom base and the other a top base. So it varies in different textbooks and how people like to talk about it. So I'm going to say the 3 here, I'm going to call that my base 1. So I'm going to call that B1. And I'm going to call the 7 my B2, my second base. And often in textbooks, they put the larger one on the bottom for some reason. It's pretty rare you see it the other way. So some kids might look at my first trapezoid here and say, hey, your trapezoid's upside down. No, it's not. That's the way it's supposed to be. Right? It just kind of depends. But those guys are called the bases. From the bases is where we get our height, and the height is, what's the word for the height in this case? It's an altitude, yeah. So I need to know my two bases. I also need to know the altitude. So let's just see what our procedure gave us. In order to get the area of the parallelogram, what did I have to do with those bases? So my parallelogram ended up being 10 by 3. Where did I get that 10 from? I had to add the bases together, right? That ended up being one side of my parallelogram, the top or the bottom, depending on how you look at it. So as far as an area for a trapezoid, first thing I have to do is add up my bases. Take base 1, add it to base 2. Put that in parentheses. Okay, what do we do after that? Once we have those bases added up, we need to identify the height, the altitude. Okay, so then we're going to multiply. That's where the 3 is. That's our height. I'm going to call it just h. So I'm going to multiply by h. Now that's the parallelogram, which is a little more than I want. So what was the next step? Divide it by 2, cut it in half, take either perspective. So I divided by 2, like that. So that's one version of the formula for a trapezoid. Base 1 plus base 2 times the height, and then divide by 2. Another way you can kind of think about this, and we'll play with this more in the next class because we're going to revisit this. Instead of writing it as base 1 plus base 2 times the height divided by 2. I claim that I can write it like this, base 1 plus base 2. That's divided by 2, and then multiply by the height. So question, is my second version correct? Okay, and we can double check with these numbers. So in my example, I had a base of 3 and a base of 7. If I add those up and divide by 2, that's going to give me 10 over 2, which is really 5. Running out of room here. And then I have to multiply that by my height, which was 3. So I got to times 3 there, times 3 there, times 3 there. And that gives me 15, which is the area I thought my trapezoid was. So it still works. It's just a slightly different order of operations. Can you tell me anything else you know about the way I wrote that? Does that look familiar in some other mathematical way? How? You know. What?
Slope.
Not
No.
slope. Slope's different than that. We did this in the beginning of the quarter this term.
Y-intercept?
No, y-intercept.
Vaguely
Take two numbers, you add them up, and then divide by 2. Mean, yeah. This is the average of the two bases. Yeah, this is the average of the two bases. It turns out if you average the two bases and multiply by the height, that totally works. So what we'll investigate next time is, does that make sense geometrically? If I look at the picture and I try to cut it up, can I still make sense of averaging the bases? Okay. Because that's not quite what the parallelogram shows us. Same idea, but or same formula, but it's just a different approach to it. So I'm gonna pause here and go back to the assignments. Oops, that's not what I want. I want to go to the home page. All right, so Chapter 14 activities scan is available here, but that scan is broken because it only has every other page. So I got to fix that for those of you on here. You only get the even or odd pages. GeoBoard app, the one I was using in class, is linked to right here. There are other companies that made these free apps that work like real geoboards. If you find a better one, let me know. That one's here. We worked and mostly finished activity 1. We mostly finished activity 2. We skipped activity 3 for now. It may come officially off the list. I'll let you know on Monday, so hold off on that for now. Activity 4, we just mostly finished that right now. So we are about halfway through section 1 of chapter 14. So we got a couple more things to do here related to circles and polygons next class. So don't worry about these for now. I'll change this due date. And then one thing you do want to look at soon is I added a new homework assignment for 14.1. You want to get that started soon. And you got a couple weeks to get that done. But the sooner you start it, the better. We're going to move along. So it's going to take us at least another day to get through 14.1, and then we'll jump into the rest of chapter 14. So we have 2 sections on 2D stuff to get a little more information so we can jump into 3D stuff. And 3D stuff kind of finishes off this chapter. There's 3 sections on 3D things. All right, over and out.